Hello everyone, I am Amar Kumar from Engineering Physics branch at IIT Patna. Today I will cover about charge and Coulomb's force. Let's start about charge. The charge is fundamental property of matter that explains a force when it is placed in electromagnetic field. As we know that electromagnetic field is combination of electric field and magnetic field. So let's take an example. If a charge Q is placed in uniform electric field E, then the force experienced by the charge is given by F is equal to QE. Here we see that if charge is positive, then the force is along the direction of electric field, and if charge is negative, the force is opposite to the direction of electric field E. And if the charge Q is moving with a speed V is placed in an external magnetic field B, external uniform magnetic field B, then the force experienced by the charge Q is given by F is equal to Q into V cross B. Okay, so here we see that if a charge is placed in electric field or magnetic field, then it experiences a force. Charge is denoted by Q, and its SI unit is Coulomb. Sorry, SI unit is Coulomb. Let's start about types of charge. Types of charge. So as we know that charge is of three types: positive charge, negative charge, and neutral charge. So let's first talk about positive charge. So what is positive charge? When number of protons is greater than number of electrons, the charge developed is positive charge. The second one is negative charge. When number of proton is less than number of electrons, then negative charge develop on the system or atoms. And the third is neutral. In case of neutral, number of proton is equal to number of electron. Discuss about properties of charges. The first property is charge is additive in nature. Additive in nature. Sorry. Additive in nature. This is due to it is a scalar quantity. So let's take example. If charge is plus 2 minus 1, then the net charge on the body is 1 coulomb. As we know that Q is equal to any, so any charge can be written as integral multiple of charge on an electron. This represents quantization nature of charge, where charge of electron is given by 1.6 into 10 to the power minus 19 coulomb. The third property is similar charges repel each other while opposite charges attract each other. Sorry, attract each other. Let's take example. We have two charges Q1 and Q2. The charge Q1 is plus 1 coulomb and the charge Q2 is also plus 1 coulomb. If both charge is of same type, then they repel each other and the direction of force is along the line joining the charge Q1 and Q2. If same, if charge Q1 and Q2 both are opposite in nature, then they attract each other. Let's take if the charge is plus 1 coulomb and minus 1 coulomb. The force of attraction take place here. Q1 is attracted by Q2 and Q2 is attracted by Q1. Let's start Coulomb's law. Coulomb's law takes assumptions. Linear size of charged bodies are much smaller than distance separating between them. Size may be ignored and the charged body is treated as point charge. Means if we have two charges Q1 and Q2 and the size of charge is too small than the distance between the charges Q1 and Q2, then we can treat the charge as point charge, and in this case we apply Coulomb's law. Coulomb's law says that force between two point charge is directly proportional to magnitude of product of charges Q1 and Q2 and is inversely proportional to a square of distance between. So force is given by this. After taking both into consideration, the force is given by this. And if we remove proportionality sign, we take a constant. We take a constant k, and k is known as Coulomb's constant. and its value is 9 into 10 to the power 9 Newton meter square per coulomb square. We also know that K is equal to 1 by 4 pi epsilon naught. Epsilon naught is permittivity of vacuum space, whose value is given by 8.85 into 10 to the power minus 12 coulomb square per Newton meter. If we want to write Coulomb's law in vector form, then the form is given by F21 is equal to K Q1 Q2 by R21 का magnitude का square R21 का cap, where R21 is unit vector. Let's take an example to solve a problem. Let's take example. If we have two charges plus 1 coulomb and also plus 1 coulomb, the force between them is given by F is equal to K Q1 Q2 का magnitude by R square, which is equal to 9 into 10 to the power 9 into 1 into 1 by, and the distance between them is 1 meter. So 1 ka square 1, which is equal to 9 into 10 to the power 9 Newton. So here we observe that the force between charges of 1 coulomb and distance between them is also 1 meter is given by 9 into 10 to the power 9 Newton. So here we conclude by, as far we have covered about electric charges, what is electric charge, its type, properties, and coulombs. So we want to revise all. So as charge is fundamental property of matter that experiences a force when it is placed in electromagnetic field, and the charge is denoted by Q and its SI unit is coulomb. There are three types of charge: positive charge, negative charge, and neutral charge. Properties of charges. So charges additive in nature, quantization of charge, and similar charge repel each other while opposite charges attract each other. After that, we come on Coulomb's law. Coulomb's law say that force between two point particle is given by F is equal to K Q1 Q2 by R square, and we solve a problem in which we have two charges Q1 and Q2 as 1 coulomb and the distance between them is 1 meter. So force acting on them is 9 into 10 to the power 9 Newton, and the charges are of same type. So here repulsion, force has repulsion in nature. Thank you.